Good day and welcome to another class on OR application. We have a small software that the link has been shared, and to download, while you can download from the internet, it is already in the link. After the downloading, when you get the software, this is the nature POM file. Then to install, you just double click or open as admin, continue, then you fill the information provided as required. So it's a very light, so name, university, course, professor. You can write your name, you can write Institute of Business Analytics, you can type OR application, professor, you can type Dr. M.A. Isiakai there. Then you click next till it is completed. So I already have it. I don't want to reopen it. So on your system, on your desktop, you will see the icon POM. So when you double click and open, this is the landing environment. These are all the types of questions you can use this to do. For some of us that has done theoretical part of this, then you can take any of the questions you have solved before and attempt to solve the same using the software. To start with, for our own, the first question is about queuing theory, so which is also referred to as waiting line problem. It's about queue. Anywhere where there is the rate of service is lower than the rate of arrival of customer or the need, there will be some queue or waiting in the system. So for this simple one, the average arrival is 15. The service rate is 20 items per hour. So we want to determine server utilization, the number of items in the queue. All these have serious formula that are used in classes that relate to them. But here we are going to use this software. So to start with, we need to look for appropriate queuing or waiting line model to pick. So if we check inventory relation, this is waiting line. Okay, then under the waiting line there are a lot of options. This particular one is MM1, the simplest one, is having only one server and the like. Exponential service time, that is the base. Now you can put title if you like. The problem we want to solve is the basic one, no cost. So let's just click OK. Then there will be opportunity for us to type. So we have arrival rate and service rate. So the arrival rate here is 15. Let's confirm. The arrival 15, then service 20. So arrival 15, service 20. So after this, we click solve. As simple as that. So the first question, now let's see the question we are trying to solve, if you can retrieve them. There are different solutions, so you may need to click some of the other solutions. For example, under the solution, you have table of probability, graph of probability to see others. So from our question here, the first question is to determine the average server utilization. So all these are directly observable from the first part of the result. Average server utilization 0.75, average number in the queue, which is LQ, is 2.25. Average number in the system, L, that's 3. Average time in the queue, WQ, is 0.15. Then average time in the system, W, is 0.2 or 12 minutes. Then average, okay, so that's the end of the average. The next one is probability of having 5 items in the system. To answer this, we need to go to this solution and open the table of probability. So if you see the structure of this probability table, the first column here is the probability of a particular number. For example, probability that there will be k. So probability that there will be 2, for example, is 0.15. Probability that there will be 6 is 0.04. But the next one is probability of having less than or equal to. So probability of having less than or equal to 3 will be 0.68. Of having less than or equal to 7 will be 0.9. So less than or equal to 3 will include probability of 3 itself, 2, 1, and 0. So if we had each of those probability like that, they should give the cumulative equivalent. Then the next one is probability of greater than. So probability of greater than 3, that is from 4 above. It can also be equal to probability of 1 minus less than or equal to 2. Probability of greater than 3 should be the same thing as probability of 1 minus probability of less than or equal to 2. So for those that are used to probability. So now probability of having 5 items in the system. So this is exactly the system. So we are going to use is equal to. So this is probability of k equal to 5. So we check k equal to 5 and pick our answer. So the answer is 0.06. Probability of having 12 items in the system. So it will be k equal to 12, 0.01. Probability of having not more than 3. So not more than 3 will mean is either 3 or less than 3. So that is probability of less than or equal to 3. So we are going to use less than or equal to k, and then we'll go and check under 3. So less than or equal to 3 is 0.68. Then the next probability of having more than 6. So that is greater than k. So greater than 6 will be 0.13. Then the last part is probability of having 2 or more. If we say 2 or more, it includes 2, then 3, and the like. So it's probability of like greater than or equal to 2. But in this case, we don't have something like greater than or equal to k. So it will be like probability of greater than 2, then plus probability of 2. So if we use that approach, probability of greater than 2 will be 0.42. And then probability of equal to 2 will be 0.14. So it should be 0.42 plus 0.14, which is 0.56. Again, probability of having 2 or more, it starts from 2 and 3 continue like that. But in this format, there is no probability of greater than or equal to k. So what we can do is to pick probability of 2, then and probability of greater than 2, so that 2 will be included. So probability of greater than 2 is 0.42. Then probability of equal to 2 is 0.14. If we add the two together, that should be probability of 2 or more. So and that is 0.56. So that is the end of the first question, which is on Q theory. We are going to move to the other question in another video.